Okay, so we are going to continue with this problem. Again, we have drawn a picture that represents the situation that's given to us in the problem. We want to maximize the length of this pipe. This length is divided into two pieces. So let's call this piece X and this piece Y. So the thing that we want to maximize is L, and the equation is L equal X plus Y. The problem we have now is having two variables. So either has a relationship between X and Y and make this all X, or make everything Y. In this case, we don't have that. So we need another variable that can relate to X and Y. So we are going to write this equation with a third variable that represents X and Y, so we can continue by finding the derivative and finding the maximum length. Okay, so when I look at this, I see what is the two things that I didn't benefit from: the width and the width. How I'm going to benefit from this? I can make this a right triangle and make this a right triangle. This is a right triangle, this is 8 because this is the width and this is 10. So I will call this angle theta and this is angle theta because these are two parallel lines. So if this angle measures anything, this will be the same measure because they are called corresponding angles. So now I can write X in terms of theta and Y in terms of theta. How? This is a right triangle, so I can use SOHCAHTOA. So I can say that sine theta equal 8 over X. That means X equal 8 over sine theta. And in this right triangle, I can do, this is adjacent and this is hypotenuse, so I can say cosine theta equal 10 over Y. So Y equal 10 over cosine theta. So this is Y and this is X in terms of theta. Now I can rewrite this equation with only one variable. So I will write L equal 8 over sine theta plus Y, which is 10 over cosine theta. Okay, now the next step is to find the derivative. So now I succeeded. I have found an equation for the thing that I want to maximize, and it has only one variable, theta. So what I'm going to do is I'm going to find the derivative and make it equal 0 and solve for theta. So the derivative L prime, this I can use quotient rule if I want. So low square, low d high, so sine theta times 0 minus high derivative of sine is cosine. Plus low square, low d high, which will be cosine theta times 0, minus high d low, the derivative of cosine is negative sine. Okay, so L prime will be negative 8 cosine theta over sine square theta. This minus and minus will be plus 10 sine theta over cosine square theta. Okay, I can start to isolate the numbers in one side and the trig ratios in the sine and cosine in the other side. So the first thing, I will move 8 cosine theta sine square theta equation by the denominator to get rid of them. Sine squared theta cosine squared theta. So when we do that, if I multiply this by sine squared theta cosine squared theta, the sine squared and the sine squared will cancel out, and what will remain? 8 cosine cubed theta. Right? 8 cosine cubed theta. And on the other side, I will multiply this by cosine squared sine squared, so that will leave 10 sine cubed theta. Now I can divide this by 10, so 8 over 10 will equal sine cubed over cosine cubed. You know, the problem is when you have two trig ratios like this, you cannot solve the equation. So by doing this, I divided everything by 10 cosine cubed. So the cosine cubed get here and the 10 get here. This sine over cosine is 10. So sine cubed theta over cosine cubed theta is, and this is 4 over 5. And this is tan cubed theta. So that means tan theta. By the way, our calculator has to be in radian mode in all the trig optimization. So when we are doing calculus, leave your calculator in radian mode. So tan theta will equal the cubic root of 0.8 or 4 over 5. So theta will equal 10 minus 1 the cubic root of 4 over 5. When we want to find the angle, the measure of the angle, we use 10 minus 1. Okay, so after we do this, we will get the theta. I don't know, I did this in my calculator. So theta is 0.8226 radian. Then we can find x. So x will equal 8 over sine 0.8226, and y will equal 10 over cosine 0.8226. I'm not sure if I did 10 theta correct. Maybe I need to check this, but hopefully everything is fine. Now you will find x and y, and you will add them, and to get L, so the maximum length will be 25.4, 0.3 feet, or meter. Okay. So I will re-explain this again. We draw a picture. We want to maximize the length of the pipe. I make it 2 parts. I have no relation to make this one variable, so I start to think of the angle. I made the 2 variables in terms of the angles. Then I wrote the equation in terms of 1 variable only. I found the derivative and I solved for the angle. I found it. I returned back and get the x and y. I added them and I get the length. If there is any mistake, it will be in the calculation, but other than that, I think everything is okay. Okay. Alright, I want to do one more example, at least to give you the idea of one more example, then you can work on your own. Okay, I read the question. A trough for holding water is formed by taking a piece of sheet metal 60 centimeter wide and folding the 20 centimeter on either end up as shown in the figure. I'm going to draw the figure. Determine the angle theta that will maximize the amount of water that the trough can hold. So we have a sheet of metal, we bend it like this to 20, 20, 20, and we want to, you can bend it in many different ways, but we want the way that we can bend it so it can pass the maximum amount of water. So the maximum amount of water, if you remember the optimization we did in example 2 when we said the maximum, do you remember the Norman window, and we said we need to maximize the amount of light? We said that we need to maximize the area. So if we maximize the area, the amount of water that will pass will be maximized. The area of this shape, this is a trapezoid. So the best thing to find the area is to divide it into a rectangle and two triangles. Okay. These two angles will be the same, theta. So we need to now we draw a picture. We know what we want to maximize. It's the area. So the area equal area of triangle, two triangles, plus area of the rectangle. Right? So the area of these two triangles is 2 because there is 2 of them. 1/2 base times height. So this is the height and this is the base. Plus the area of the rectangle is the height times 20. This h times 20. 20h. Again, the problem we have now is having two variables. So we need to find b in terms of h or h in terms of b, or both of them in terms of theta. And this is what we're going to do because we don't have a relationship between b and h. So we're going to find h and b in terms of theta. We can say that in this right triangle, sine theta equals h over 20. So h equal 20 sine theta, and b and cosine theta equals b over 20. So b equals 20 cosine theta. Now we can rewrite this equation in terms of theta, and we find the derivative and make it equal 0, find the angle and maximize. This is the idea. I will have a question like this in the homework, so try it and then send me your questions by Sunday night, because we are celebrating our Easter this weekend, so I'm not going to be online. So send it on, you have till Monday to work on this, and then I will answer your questions on Monday, okay?